All right, on RT5-2, we're going to draw reference triangles and learn a whole lot of vocab. So we're going to think of angles as they're really rays that have been rotated. So that initial side is your starting position, or that pink line that I drew, and your terminal side is the ending position. So you really picked up that first ray and you rotated it by however many degrees here, about the vertex there. In standard position, the vertex is always at the origin, and your initial side is always on the positive x-axis. So when I ask you to draw reference triangles in this class, assume it's in standard position unless told otherwise. So your initial side would always be here, and then you would rotate however far to draw in that final position. Your positive angle always goes counterclockwise, so you'll move that direction. If the angle is negative, then you're moving clockwise, so that direction. So we're going to fill in some vocab. That green side is where your initial side is. And that red side then is where the terminal side is. The blue is your positive angle. And the orange is your negative angle. The purple then, if I make a triangle out of that terminal side, that is what we call a reference triangle. All right, so we're going to draw some of these. And on all of them, I'm going to start with a graph. So we're going to draw a reference triangle if theta is pi over 6. I always start with my initial side. So I'm actually going to copy this because I'm going to need it on every single one. And then I'm going to think, okay, pi over 6, I know that that's the same as 30 degrees. So I'm going to eyeball about 30 degrees. And we just got to get close. I've got that terminal side now, and I can drop in a triangle. I'll do the same thing for example number 2. This time, I'm like, ooh, 4 pi over 3. I'm not entirely sure where that one ends up, but I know if I count by 6 that I can get there. So I'm going to count up to 8 pi over 6. And I'm going to picture my entire unit circle split into sixths. So I would have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6 would be right here. So there's my terminal side. And then I'm going to drop in that reference triangle going up here. I'm going to do the same thing with pi over 4. I know 1 pi over 4 is at 90 degrees, so I just need to count around until I hit 9 pi over 4. So I've got 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. And I get a picture like that. I know pi over 2 is at 180 degrees. So I'm just going to count back and forth until I get to 7 over 2. So I've got 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. And on this one, because it's just a straight line, I'm not going to draw the triangle bit in because how could I? I'm just going to leave it like that. All right, on these next ones, I'm going to have to use my noggin a little bit. It's more than just counting around. This time I'm going negative. So I know positive pi over 4 is that 45 degrees. This time, since I'm going negative, I'm moving this direction. So I end up there. Drop in that triangle, and I'm good to go. I'm going to clean this up before I start drawing. So I've got 3 times 2 pi thirds. My 3's will divide out, so I'm drawing a reference triangle for 2 pi. Well, 2 pi is the entire thing. So my picture looks like that. And if I want to be super clear and prove to Miss Cronin that I didn't just quit halfway through, I can draw in 2 lines, but otherwise I'll just assume you know what you're doing.